The next session is going to be even more interesting because we have some wonderful industry leaders with us, and they are going to share their knowledge once again with all of you. I hope all of you are sharing your stories with us on social media, because these stories are going to be very interesting to go by. Once this conference is over, we're going to revert to you, and I'm sure it's going to be worth looking at every picture, every story that you're going to put up on social media, on Facebook, on LinkedIn, and on X. So we're ready for this fireside chat. I would like to request Mr. Arnab Basu, who is going to initiate this whole conversation. He's the advisory leader, PwC India. May I request you, sir, to kindly come onto the dais and take your seat. And a huge round of applause, please, ladies and gentlemen, dear delegates. Mr. Arnab Basu is here. A very good afternoon to you, sir, and a warm welcome to you. I'd like to request the speakers, Nishita Bailarsingh and Nikita Bailarsingh, to kindly come forward, please, and a huge round of applause for these wonderful ladies. I'm sure we are going to have a very interesting conversation. So I hand over the session to our moderator and our speaker, Mr. Arnab Basu. Sir.
Thank you. Good evening, everyone. It's indeed an honor and to be here and to sort of welcome you all to this session on sustainable disruption. Since morning, we have been hearing many speakers talk about it in different ways. We had discussions on how you can do sustainable disruption. Mr. Pramanik talked about how you can look at sustainability amidst disruption. And of course, we heard from some of the tech panels today. So at a time when I would say tech is moving at an unprecedented pace, it is, I think, very vital to ensure that the innovation that we are investing in, that is aligned with sustainability. And both from a business perspective as well as for the planet. And this alignment is something that we, as corporate citizens, I would probably say we need to be deeply committed to as we work with organizations. And we have to integrate sustainability into the basic fabric of our strategy. And today we have the privilege of hearing from two extraordinary leaders who embody this very philosophy, Nikita and Nishita Bailarsingh, co-founders of Nexus Power, who are pioneers in clean tech innovation, in transforming agricultural waste into bioorganic batteries for electric vehicles. Their work not only disrupts the conventional battery market, but also champions the principles of a circular economy, aligning with the core values of sustainable growth that organizations across the sectors, including ours, strive to achieve. But before we get into this conversation and we start hearing from them, I do want to put in context for the audience a bit of context around what we in India are seeing around our future of fuel and how we look at that, the future of fuel going into the India of 2030. If you look at India's energy demand right now, it is expected to double to 2040. Obviously driven by economic growth. Urbanization is a massive, massive issue right now which we have. While we need urbanizations, but we also need our cities to be decongested. We need more cities to come up. And if you look at our climate commitments, what India has been committing under the Paris Agreement in terms of cutting emissions, in terms of looking at how do we cut it by 35%, in 2030 from our 2005 levels. I think these are not easy challenges to overcome. And if you look at what we are doing on battery technology, for example, I think energy storage would become a very, very critical part of India living up to this commitment. And there's been a lot of research which has been going on into battery storage systems to address the intermittency of renewable energy sources. We have been having research into advanced batteries like solid state batteries, alternative storage methods like pumped hydro, thermal storage. So we have been doing a fair amount of that. And if you look at what we are looking at today in terms of our EV plans and our charging infrastructure, again a fair amount of paths to be covered. While we are promoting electric mobility to reduce the reliance on fossil fuels, I think the kind of adoption which India is striving to achieve by 2030 is very difficult to do if we just follow the conventional method. And that's where I think today's conversation becomes very, very important. Because when you think of widespread EV charging infrastructure, when you think of battery swapping stations, when you think of what most of the fuel retailers started to have in terms of EV charging possibilities, one of the thoughts which very clearly is coming out is what are we doing around bioenergy, what are we doing around waste to energy, and how do we look at utilizing the agricultural byproducts, how do we look at municipal solid waste, how do we look at other biomass for energy generation. And with that kind of a thought in mind, if you think of what Nishita and Nikita have been able to achieve in terms of disruption and in terms of sustainability, they are truly embodying what we would probably say that a classic example of sustainable disruption. And in this session, we will obviously explore how their vision and journey exemplify this, in the coming days. But to open it up, maybe I'll go to you, Nikita, and start with you. And of course, both of you are partners in crime, so to say. So please feel free to add on. But it would be really interesting for the audience to briefly understand your journey and explain how this technology is disrupting the conventional EV battery market.
Sure. Good afternoon. First of all, thank you so much for having us here and for hearing us out in this fireside chat. So, what we started off with was, it was not the idea to make, to have a sustainable disruption. We did not have this in mind that we wanted to create something different. The basic idea was, we were in college and we were figuring out with entrepreneurship, which has been our calling since childhood, and electric vehicles and energy storage and the sustainability part of it was really booming at that time. So we got deeper into the entire idea of sustainability and did realize that electric vehicles are picking up, but the batteries that we use are not as sustainable as they might sound. So the concern for us was that we are still using rare earth materials, which is bound to finish at one point of time. And at the same time, it is not as safe for the people and the planet collectively. So the mindset for us was make batteries out of something which is abundantly available. Second, something which is easy to access, something which is not harmful for the people and the planet. And that's how we began our research in battery technology. In parallel space, we heard of this news of the air quality index going down in the northern parts of India, which, being sustainability enthusiasts, was another concerning point for us. So, it was a very vague thought. Both of us were chatting one night on the terrace and we were like, if we use that crop residue which is creating this pollution and we try and make our batteries out of that, and if that works, I think that this would solve two major problems. One would be the air pollution issue, the other would be the battery disposal issue. So it kind of sounded really fascinating. So COVID hit after that, and during COVID at home we said we have to do this little bit of experiment. So we started by experimenting in our kitchen, and we used a little bit of the crop residue. We tried to extract whatever we could, and we made a basic battery with salt water and hydrogen, sodium hydroxide as our electrolyte, and that actually worked. It gave us some 2.5 volts, and we were delighted that evening that basic crop residue and detergent powder could give us 2.5 volts of current in a battery, which was very raw. I think that was where the circle of Nexus got complete, and we realized that this has tremendous potential, and I think that is when we decided, let's plunge into it and let's start working on it. From there, of course, we needed a team. We started, gathering the people who could work on it hands-on, and then from a very raw form of the battery, we had to go down to a processed and finished product, which we started eventually. So 4 years down the line, we've increased, tremendously grown in team size, in research, in the product, and today when we have that product being tested out in electric vehicles, in stationary storage applications, I think somewhere back of the mind where we had this idea of making batteries which are not harmful has certainly to some point been achieved. And there's a long way to go for sure, but yes, these batteries are biodegradable, and that's for us something very close to our heart.
No, thank you, Nikita. And when I was discussing with Nikita, I did realize that there's a huge amount of research and chemistry involved, which we normally don't think of, right? We think of a startup, we immediately start thinking of monetization, we're thinking of, how do you bring it to your customers and all that. So when you think of the real journey of, really doing research in chemistry and getting to where we are, I'm sure you would have this conflict between breakthrough innovation and environmental stewardship, right? Because I'm sure at every stage there would be some amount of breakthrough innovation which is possible, but then, how does it, sort of line with your vision of being environmentally, responsible? So maybe if you can just tell us a bit about that journey into research and how you tackle that constant push and pull between innovation and the climate.
Thank you for that question. In fact, as a team, it's been very hectic, to be honest, to stick to a particular path, because we have doctoral scholars, we have researchers who spend almost 15, 20 years in developing different technologies, different chemistries. They've worked on cell technologies. Now to bring 15, 20 people together with different mindsets and different thought processes to think on a linear equation sometimes is really hectic, and I'll be honest with that. And there are times when you're actually working on a certain chemistry, you're trying to say, if I break down that cell chemistry, there are 4 elements primarily. There's the anode, the cathode, the electrolyte, the separator on the element point of it. Now, when you start working on one element, we have to make sure that all of them align together. And then there are times when you almost crack the anode, but somehow lack on the cathode. So you kind of feel like going back and doing the anode again, and that's when 20 people again come back with 20 different thoughts. That we can tweak this, or we can change the percentage, or we can change the concentration. And then you try and do that, and then again go back, and then realize, probably there's another element that you have to optimize. So a lot of these back and forth keep happening in terms of technology, and I think at every element that we worked on, every moment that we've developed in the last 4 years, beyond 4 years in fact, there have been points where disruption is clearly visible, where innovation is visible, where our team has actually gone out of their comfort zone to try and figure out something which probably they've never done before that, to just see if that aligns with the other materials in that cell. So that's the kind of difference that we try to make. That's how innovation and R&D has been. And from the very understanding of it, research and development means going back and forth, developing something, testing, and then it's a loop that continues. And that's how R&D has been. I think even today, though we have a product which is a benchmark, which is running large-scale pilots and trials in the market, I think in the back end, the R&D team still sits down to think that they can make it even better. And that's how R&D keeps going on for us, back and forth. Every day we learn, every day we do something new, every day we experiment what can be better, what we've done wrong, and what we can improve. And that's how things keep moving.
So as you went on this journey, just to follow up, Nishita, on this for you, that how did you look at the availability of raw talent, who would work with you? Because you would need a very different talent, right? So it's not like a tech startups where, tech graduates are waiting to sort of join at zero salary and say that, okay, give me some stake and I'll stay with you for some time. Yours is a very, as you said, it's a field of chemistry. It's not really a field of, information tech. So how did you handle that? And maybe another question which Nikita, you can talk about is, considering the amount of CIOs and, in the room, what role did data and technology, information technology play as you went about this R&D journey? So, just the two.
I think absolutely something that we had to ponder upon for a long, long time to understand what exactly and how exactly do we have to get the team together. So one of the primary things in the entire development phase was the different aspects of the process, right from the collection of the material to the final end product. And that's where we realized that typically you will not actually find one person who's experienced in all of it. So when we started hiring for the team, when we looked at who can add value and how that can work for us, we actually broke the entire process into smaller processes. So some part of the collection involves biomaterials, and then there's a biotechnology, then there's some kind of cell chemistry, there's material synthesis, there's cells and cell manufacturing, there is battery assembly, and so on and so forth. So each of these processes were broken down, and then we looked at talent in each of these processes individually, and then brought them together. So then when we stitched the team together, it was different pieces of the puzzle coming together, wherein we have a person specialized in biotechnology who just understands the agricultural residue and the raw material out of that, and then the next person was somebody who understood the cell part of it, who once receiving the anode, the material can make the anode and the cathode. And then the next person can fabricate the cells out of that, bring that together to make a cell. And then the next person kind of packages it into the battery. And that's how we had to build the team together. And honestly, it's not been an easy journey to build the team together, but what really resonated with us was the kind of value that person can add on and the way he picturizes the entire thing. So it's about looking at the bigger picture. I mean, though you're being hired for a very specific zone, which is probably the cells or the materials, but if you can actually visualize that entire journey together, and that resonates with us, and you're equally willing to add that value, that's what really counted when we tried to build this team together.
Thank you.
I'll just add on to what she said. So when we started hiring, we decided to work on battery technology. We decided we need to hire electrical engineers. Eventually, when we were hiring these engineers, we realized, no, we need chemical engineers, the ones who understand chemistry. And it took us 1 year to actually realize that we are not in the business of chemical engineering, we are in the business of material sciences and biotechnology. So there was this phase of 1 year where we hired the first bunch and realized they don't have the expertise to work on the chemistry. Then we hired the second bunch and we realized, they can't mix the crop residue part of it with cell technology. And now finally, 1 year later, we realized, oh, okay, so this segment department is called material sciences. And that's how then we started working on people filtered to material science and biotechnology. So that was the journey that we had. Coming to your second question that you mentioned, how information technology has really played a role. I think most of the data that we work on gets simulated into softwares to generate possible outcomes, which helps us understand certain results and the margin of error. So we have this liberty to decide whether we should physically experiment it or just consider the value that the software is giving us and decide whether we want to go ahead or not. So that's been one very helpful phase that IT has played in the entire research part of it. Secondly, your day-to-day operations and your data and the privacy, the storage of all of that material gets really easy when you have IT involved in the entire operations. But of course, we are more into a very physical R&D kind of a space. So we, day in and day out, actually go into physically experimenting things. But yeah, these are certain elements that do add value and they kind of make work easier and I would say they make things more doable. Because if there are 10 experiments that somebody has to perform and you know that 5 of them would not give you a positive result, you only have 5 on your plate to actually try and work on.
No, lovely. See, one of the things which every new startup sort of struggles with and aspires to is how do you make the solution scalable, right? And obviously you are in a segment where, as you rightly said, that there's a lot of latent demand in the market if we get a product like yours. So when you look at your product, what are your thoughts around scalability of the business, and how do you look at managing scalability and operational efficiency? Because you have to remain eco-friendly, but at the same time, how do you look at scalability as a solution?
In that entire process that we're building and the product that we're building, the entire structure is very process oriented. There are multiple back and forths, there are multiple different aspects where we can add value and create a difference. So in terms of scalability, what was important for us was to be able to replicate the same material that probably we first did at a milligram basis to go up to almost kgs and then tons and then beyond that. So that was one very important aspect, and that involved optimizing the process of extraction time and again, and then cloning the same thing. So when we talk about scalability for us, if you look at cell manufacturing, which is more or less accepted globally, I mean you look at the Chinese and European markets making lithium-ion cells, now that part typically is established and scaled, so we understand how that works. But reaching that, wherein the materials come in, and then when we synthesize and build the cell, that is what we had to optimize and then scale. So in terms of being able to clone it again and again, that's where the actual question of scalability comes in. But we started off with milligrams, now we've grown to almost kgs and then going to tons and then going forward. So we do realize that every time you try and double the quantity, you've been able to optimize that process that many times to make sure that if I start from 0 to 100, I am reaching the same result again and again, and that's how we've been able to optimize the process for the scalable part of it. But if you look at the industry as a whole, now it's actually almost $1 trillion industry globally, and it's growing rapidly. I mean, I think it's doubling every 2 years, and that's how fast the energy storage and battery industry is growing. So for keeping up to that pace, the demand is huge, and I wouldn't say that we would be able to kind of pull the entire market together. But the whole idea is to be able to optimize and be able to reach that gap in the demand and supply, which probably is widening with each passing day. And the very reason is because of lack of materials, because of the environmental pollution, because of the disposal problems and so on and so forth. So what we are looking at is being able to scale to a level where we can meet this gap and then eventually be able to build a bigger share and bring in this optimization and give us the be able to provide that difference in terms of the sustainable part of it to the environment as well as the product as a whole. So sustainability is at the heart of it. But since Nishita is the CEO, we leave tough decisions to her.
Lovely. So tell us a bit about your, immediate plans in terms of now that you have a fairly good handle on the product. What are your thoughts around taking it to market? In a country like India, where, as you said, if you look at the current EV market, there's a lot to be desired in that market itself, whether it's around the charging infrastructure, whether it's around the batteries, how if need to swap batteries, how do you look at disposing batteries, how do you look at people making that move at the same time, such a huge huge country. Can you really start with something in one particular place? Because if I'm going to go from Calcutta to Orissa, do I need to have something available at both ends? So what are your thoughts around, really taking it to market and the, immediate next steps which you are thinking of, the big steps?
So the immediate next steps, in fact, what we are already in process right now is where we've put these batteries in the market. So we focus a B2B space. We are not looking at the consumers. We are looking at the OEMs who will be fitting these batteries into their vehicle, and then they have their own network and chain of distribution. So as of now, we are pushing in these batteries with the OEMs, wherein we're spending 6 months with the OEM tracking the data. So that data is very important for us in terms of understanding how the battery is working with the vehicle, what is the input, and what is the derivative that we're getting out of it. And if there is any scope of improvement, and if we can make things better. So that's primarily the first step of ours for stepping into the market. Eventually, I think we'll start really leaving that control on the batteries, where we, 6 months is what we want to track the data for, and then leave it to the OEMs to keep running the batteries. Then we come back to the disposal. So we complete the loop there. Because one major aspect of our product is the disposal part of it. So once the life cycle is over, you can actually open it and leave it in the soil, and that's how it naturally biodegrades. So as of now, these batteries give about 4.5 years of life. So we would only come back 4 years later to throw it into the soil and see how things progress and what is the ultimate derivative. But the first steps right now that we see is interaction with the OEM in both electric vehicles as well as the energy storage, stationary part of it. Because if you consider the industry today, it's all things energy, right? I mean, like right from the smallest of the toys to the as big as even fridge, AC, electricity as a whole, grid storage, everything is energy, and that's the kind of impact batteries can have eventually.
So, as you talk about OEMs, you obviously entered a field which is a very, very highly competitive, field with very large existing players, right? And some of the players are from this city as well. So, what has been your experience with how Compete has, looked at your product? Have they looked at it as a new innovation which can disrupt their business? Have they looked at it as something which is, nice to have? Let's see what they get to. If they, get somewhere, we'll start, getting into it. So, what's been the general reaction or response from Compete?
To be very honest, we haven't come across somebody who's not been excited about the kind of work that we are doing. And naturally, people really want to see the results and the outcome, and we're all looking forward to what happens when it actually steps into commercial manufacturing. So there has not been much of tussle with the competition yet, because naturally, I think most of the people working in batteries are inclined towards sustainability, and they are more than happy to look at new technologies coming into the market. But we are working with two-wheeler and three-wheeler electric vehicles for now, and the very reason for choosing that segment is because there is a readily available market in India. The two-wheeler OEMs have sprouted up like mushrooms in the country the moment the EV revolution happened, and I think approaching them and trying and testing the batteries in their vehicles was easier than reaching out to, say, four-wheeler manufacturers or so on and so forth. So that's the reason why we stepped into that industry, and as I said, people are really up to try it and experiment and see what happens. But having said that, there are so many parameters that we do have to study eventually going forward, and that's the reason why we want to take some 7-8 months to do these tests through the trials. Once we are sure of what's going into the vehicle and then what's coming out of it, I think that's when we'll go into the commercial lines. But we are happy to collaborate, as I said, with even the competition, whoever is willing to take up through, I would say, as a licensed manufacturer, or maybe whatever integration we could do, because as I mentioned, sustainability has been at the heart of it, and it would be okay on our part to go ahead and take that plunge to collaborate rather than compete. It's fairly simple. I mean, the idea was to meet that gap, which is presently widening between the demand and the supply. The demand is growing, it's huge. But from the manufacturer point of view, the supply hasn't been that good. So the idea is to be able to meet that gap first. So we're not really looking at, eating up somebody else's market share, or kind of just spoiling the entire space and getting in and piling up the entire thing with us. The idea is they are falling short somewhere, and we see an opportunity there. So we push in and then eventually create the sustainable impact.
No, lovely, and I think on that note of offer to collaborate rather than compete, maybe I'll probably take some questions from the audience. I don't want to, sort of hog the entire Q&A time, so any questions from the audience? Anyone? Yep. I see a hand there. Can we get a mic to him, please? Okay, go ahead.
Yeah, pretty much. I mean, for us, the supply is also of utmost importance. So one of the primary parts of our supply does involve the farmers and the residue that has to come from them. So that part of the entire chain only fixes well when we are able to procure a raw material. It's available to us at the moment we need it, and we're able to process from there. So I wouldn't really disclose the entire plan as to how that is connecting for us. But yes, supply chain and the entire planning around it is of utmost importance for us. And we've been working around it to be able to standardize it. Not only at the smaller quantities, but also when we're looking at tons and beyond tons to be able to store and be able to extract our material. Because we're looking at scalability at that point of time.
Thank you. So if there are no more questions, I think I would like the entire audience to give a warm round of applause for Nishita and Nikita. More power to you both, and may your sustainability journey continue at full steam ahead. Thank you. It's been a privilege to talk to both of you, and thank you on behalf of ABP as well. Thank you.
Thank you.
Thank you very much, sir. May I request Mr. Dhruva Mukherjee to kindly come on stage and felicitate our moderator and chairman and our speakers here today. We'd like to thank our speakers, Nishita Bailarsingh and Nikita Bailarsingh. They are the co-founders of Nexus Power and Forbes Under 30 alumni. And they were in conversation with Mr. Arnab Basu, who's the advisor leader, PwC India. Thank you very much, sir, advisory leader of PwC. If you could just step forward for the photograph. Thank you very much. Ladies, thank you for your valuable story sharing, and thank you, sir. Thank you very much. We'll request you to take your seats in the auditorium.